Hello everyone, welcome back. In this session, we will create an Agent Network 2.0 project step by step. Before we begin, let's review the platform setup readiness and few prerequisites. First, you need Visual Studio Code with Anypoint Code Builder and MuleSoft Vibes enabled. I have already created a dedicated session explaining how to configure Anypoint Code Builder and set up MuleSoft Vibes for development. Please watch that session first. I'll include the link in the description below. Second, log into Anypoint platform and ensure that your Anypoint organization is connected to a Salesforce org where Agentforce and Einstein are enabled. Third, make sure the user creating the Agent Network project has all the required Anypoint platform and Salesforce permissions. Once these prerequisites are complete, you are ready to create your Agent Network project. Now, let's return to Anypoint Code Builder. Here, you will find the Create an Agent Network project option. On the next screen, provide the project name and select the appropriate Anypoint business group associated with your Anypoint platform. And click the Create Project button. Anypoint Code Builder automatically generates a ready-made Agent Network project. The project includes 3 important standard template files, already structured and ready for configuration. These files provide the foundation for defining your Agent Network, its assets, connections, broker behavior, and orchestration logic. Now we have an option to configure the project manually by updating each file and defining every component step by step. However, I'm going to use MuleSoft Vibes to accelerate the development process. I'll paste my prompt here and provide the following requirement. Build a travel planner broker that can plan multi-city trips, invoke the flight MCP server to search and book flights, and use an LLM to generate a complete travel itinerary. Let's submit the prompt and wait until all the tasks are completed by the MuleSoft Vibes agent. Alright, the MuleSoft Vibes agent has completed all the assigned tasks. Let's review the changes it has made to our Agent Network template project. First, let's quickly examine the agent script file. Here, you can see 3 actions: search flight, book flight, and get flight status. Next, we have the trigger, which receives the incoming request and passes it to the orchestrator. The orchestrator uses the configured LLM to understand the request, reason about the required steps, and execute the appropriate actions. It invokes the MCP server to search for flights, book the selected flight, and retrieve the booking status. The execution result is then passed to the router, which evaluates the booking status. If the booking is successful, the flow generates the travel itinerary and returns a successful response to the caller. If an issue occurs, the router directs the flow to return an appropriate error response. Now, let's move to the second file, the Agent Network configuration file. This file contains 2 important sections, the asset registry and the connections. The registry defines 2 inline assets, the MCP server and the LLM configuration. The connection section also contains 2 connections, one for communicating with the flight MCP server and another for connecting to OpenAI. The broker's agent card have also been updated with the appropriate names, descriptions, capabilities, and skills. Finally, we have the exchange.json file. It now contains the 2 assets that will be packaged and published to Anypoint Exchange. The required runtime variables are also defined, including the MCP server URL and the OpenAI API key, which we will securely provide during configuration or deployment. In the next session, we will publish this Agent Network project to Anypoint Exchange. In the following sessions, we will build the flight MCP server, connect it to our broker, and explore the complete Agent Network implementation in greater depth.